Hello, everyone, and welcome to Science Explosion. My name is Zach, and this is Hudson Public Library. So I'm going to get this oil started cooking, and then I will talk to you about what you need to do to get ready for this. So I'm going to do this because I know it'll take just a little bit of time for this to get fully heated. But don't worry, I'm going to tell you what your first step should be to get to this point. I just don't want to leave you waiting for too long. There we go. Perfect. All right. While that's heating up, let's get this started. So today we're making fried ice cream. I'm really excited about this one. So if you want to get caught up to the point that I'm at now, you're going to want to take a couple steps first. So first of all, you need some ice cream. So you're going to want to scoop it out into nice round scoops. So if you have an ice cream scoop, that's great. But if you don't, you can use a spoon and just kind of shake it with your hands. Just make sure they're clean. I just washed my hands right before this. So you want to scoop those out. Scoop out 4 to 6 scoops of it. And then you're going to freeze those again. So you'll get the nice round scoops, and then you will put them on a baking sheet or in a container, freeze them, and you'll want to do that for at least a couple hours. I think 5 hours is a good benchmark for that. All right, so once you've done that, then what you're going to do is you're going to whisk up some eggs, but egg whites. So you want to separate the whites from the eggs, and you can actually use the shell to do that, but you just don't want to get the yolk in there. And there's a very good reason for that. So for this whole thing, I'm going to tell you why the steps we're doing are important. So freezing the ice cream, first of all, you want it to be as cold and as hard as possible. But the egg whites is because there's a lot of protein in the egg whites, but there's no fat in them. And this is going to be really, really important later. It's also going to be important for the taste of the food. So you don't want to just whisk an egg together, but you are going to whisk the eggs together, the egg whites, until they're stiff. They're going to form little peaks. So you're basically making a meringue here. If you've ever seen like a lemon meringue pie, that stuff on top of it. So if you were adding sugar into it, you'd be making an actual meringue. But just with the eggs, you're going to do that until they're nice and frothy and they stand up on their own. So I did this with just mixing it by hand. I will tell you it takes a little over 5 minutes to do that. So it takes a little while. If you have a hand mixer, you can do that much easier and much quicker. But I wanted to make sure that I could recommend to you that it is okay to do that by hand. All right. So you'll get that all mixed, and then while you're doing that, you're going to mix together your coating. So just to recap for the ingredients you're going to need so far. So you need ice cream, you need egg whites. Now we're going to make the mix. So I'll tell you what is in that. So the first thing you'll need, and the most important part, is going to be some corn flakes. Now if you don't have corn flakes, you can use another type of cereal. You can even use breadcrumbs if you wanted to. Also, you wouldn't necessarily have to use anything like this. You could use a cake batter. If you already have cake batter, or if you want to make some, you can completely skip making this mix and use that instead. It'll work just as well. Actually, a little bit better. But I want to make sure everybody can do this. So you need corn flakes. You need sugar, not too much. And you need cinnamon. All right, so you're going to take, and the recipe I followed, I found out I really had to double it to get as much coating as I wanted to, because I think you want to get a good amount of coating on this. So what you're going to do is mix a cup of corn flakes with 3 teaspoons, that's teaspoons, not tablespoons, of sugar, and 2 teaspoons of cinnamon. And you're going to crush that all up. So I used a bowl and just used the cup to crush that down. So you're going to mix those all together. So remember, that's mixing the corn flakes with the cinnamon, with the sugar. Crush those all up. I can say that that is starting to heat up. We're getting closer. All right, so once you have that crushed up and you got your egg whites all whipped up together, then your ice cream balls should be really well frozen if you've left them frozen so far. So then what you're gonna do, take out your ice cream balls, make sure your hands are clean because it's easiest to do this with your hands. Now you might wanna actually wear gloves because this is gonna be very cold. So you're gonna take the ball of ice cream and then you are going to dip it in those egg whites, make sure it gets completely covered, and then after that, you're gonna dip it into your corn flakes. So remember that's your crushed up corn flakes with sugar and cinnamon. So you're gonna roll it around in that, and then you're gonna refreeze that for at least 5 hours. Now I've just done it overnight, both of those steps, and I can show you what that looks like at the end. Oh, looky, they froze together a little bit. I kind of expected that to happen, but that is okay because I'll just break them apart. Reshape it just a little bit here. I uncovered a little bit of the ice cream, so I'm going to fix that real quick. So this is what it should look like before you cook it. So remember the steps of that. Get ice cream in a ball, then freeze that for at least a couple hours. Overnight is best. Then dip that into whisked egg whites, and I use 3 egg whites, by the way. And then after you got that completely coated, then you're going to want to coat it in your mix of corn flakes, sugar, and cinnamon. So you'll want to get that covered as much as you can. You shouldn't be seeing any ice cream on here. Now I messed mine up when I got it out so I can see it just a little, but the better you can do, the better this is going to work. All right. And if you want a thicker coat, you can always do this twice. You can get more egg whites, coat the outside of this, and then put it with more of a corn flakes mix on the outside of that. But you want to make sure that this has a really good coating on it. You don't want to see that ice cream. And you're going to be able to tell why when we actually start to fry it. All right, how warm is this getting? Getting there. Just a little bit longer, and I think that'll be ready. All right, let's get this guy ready. All right, so let's talk about one of these ingredients. Well, actually, let's talk about a couple. Sugar. All right, so why do we want sugar? So sugar is mainly going to be for the taste of this. So sugar is going to give you that sweet taste. I think that one's fairly obvious. I think everybody can kind of guess that. But it's also going to help with something while this cooks. So I've talked about this once before, and it's called the Maillard reaction. And it looks like Maillard is how it's spelled, but I believe it's pronounced Maillard. And that is the type of thing that causes food to brown when you cook it. So if you make caramel, if you toast, if you cook meat like a steak or a chicken breast, when it turns brown, that's what that is happening. And it's basically caramelization. So it's turning sugars and starches brown is what's going to be happening with this added sugar. It's also just going to make it taste a little bit sweeter, which makes it a better dessert. All right, now let's talk about cinnamon. I find cinnamon a really interesting ingredient in this. So cinnamon, I think everybody who's had cinnamon, which I would guess is probably everybody here, you know it's got a really distinctive taste. It's kind of a sharp taste. You could almost call it spicy. So why are we putting cinnamon in this? Well, the same reason that you put cinnamon in a lot of desserts. So because we have the sweet in this, when we add spicy, it helps to give it what cooks would call a more rounded out flavor or a deeper flavor, depending on who you talk to and how they call it. By the way, I forgot to do it again, but I have got my ice cream balls sitting on top of this right here, pot holder, so that they're not sitting directly on the sink. And let's see if you can figure out why I'm doing that after I talk to you about how this dish works. All right, so cinnamon. So cinnamon is spicy, But have you ever stopped to consider why cinnamon is spicy? So it's one of those questions that you might not have ever asked yourself, but it's a really interesting answer. So the reason cinnamon is spicy is the same reason why most things are spicy. So have you ever wondered why broccoli or mustard or peppers, why all of these things have such a sharp flavor to them? Or have you ever wondered why herbs and spices have the flavor that they do? So a piece of spinach is really mild, but if you eat something like rosemary, it's got a lot more of a distinct flavor. Well, the reason for those and the reason for cinnamon is all the same. It's because it's now don't freak out, wait for me to finish this, it's a poison. Yeah, so that's right, but not for you. So don't worry, you can eat cinnamon, you'll be fine. Just like you can eat mustard, you can eat broccoli. I love broccoli, by the way. You can eat all of those things, but it's a poison for bugs. So plants, keep in mind that if you see an animal, how is an animal going to protect itself? Well, it can move, it can use claws, it can use teeth. How is a plant going to protect itself? So it can do a few different things. It can grow thorns, it can actually grow things that make animals want to eat them and help to spread the seeds. That's what fruit is. But some plants have decided, not really decided, that's just an easy word to use here, but some plants have evolved the ability to have chemical defenses in them. And so imagine a caterpillar eating some mustard greens. Well, that mustard green plant, it doesn't want those caterpillars to be eating it. So over time, it develops a poison inside of that. And so then the caterpillars, they can't eat those anymore. But then those descendants of that caterpillar, they can. Some of them process that poison just a little bit better. So then those mustard greens get a stronger poison. Well, then what do you think happens? You might be able to guess this. So the descendants of those caterpillars, some of them can process the higher levels of poison in there, and then it keeps going. So you get stronger and stronger poisons. So that's why when you eat mustard seeds, there is so much flavor in them, and that flavor is actually something that's evolved to make it so that caterpillars can't eat them. That's the same reason why broccoli has such a sharp taste. By the way, mustard and broccoli are in the same family. They're very closely related. So that's the same thing for cinnamon. So if you've never seen what cinnamon actually grows, I'm going to show you. You can see a picture of it right there. So that's cinnamon bark. Now, I will say this little aside, most cinnamon doesn't come from a cinnamon tree. It comes from another kind of tree that's related to that, and most cinnamon in processed foods is just completely artificial. But if we're talking about actual cinnamon, it's because anything with a really strong flavor that you get from plant, herbs and spices, there's a really good chance that it's basically just a defense against being eaten. But we are so much bigger than caterpillars. So a fatal dose of mustard poison for a caterpillar just tastes a little spicy for us. Think about a teeny tiny caterpillar compared to us. So then when we eat something like broccoli, we're like, oh, it's got a nice spicy flavor to it. So it's actually tastes really good to us. So I just think cinnamon is one of those really cool things. So, all right. So you've got your ice cream all rolled up, ready to go. So remember, freeze the ice cream into nice round balls. Then you're going to coat them in 3 egg whites that are whisked until they are frothy and can form a little bit of a peak when you get them out. I just used a hand whisk like this. Then you're going to coat them in that. Then you're going to coat them in a mix of cornflakes, sugar, and cinnamon. All right. So once you've got those, you're going to freeze them again. I'm just going over this for in case anybody forgot. So repetition is always a useful part of learning. All right, so then you might can smell like, oh, well, that means it's probably about hot enough. All right, then you're going to freeze these I did it overnight, but I think if you give them at least 5 hours, that should be good. And then you're going to heat up some oil. Now, we're not pan frying. You want to deep fry this. Now, I didn't have a whole lot of oil, so I'm going to try to do this by pan frying. But the best way you can do this is deep frying. Now, you want to turn it as hot as it can go, as long as you don't happen to have a stove that gets extremely hot. Now, I'm using a hot plate, which is why I've let it heat up for so long, because this doesn't get terribly hot. But you want to heat this up very high. So put your oil in that, and you want a fair amount of oil. Now I'm going to start with just one here, and keep in mind, this is going to be a very fast process. Probably a maximum of 10 seconds is all you want to cook this for. And that's very important to keep in mind. I'm going to get some water before I do that. When I talk this long, I always need more water. All right, so I'm going to get one of these. I've got my bowl ready to go. So what I'm going to do is I'm going to put this in the hot oil. I'm going to flip it very quickly, and then I'm going to take it out. All right. I'm going to make sure all the sides are covered. And you should see it turning a nice golden brown. Just a little more, and done. That's it. That is your ice cream. Now, let's do a topping. So you can do chocolate sauce or a nice syrup, and I happen to have strawberry syrup here. So I'm going to quickly pour strawberry syrup on top of that, and voila, that is the dish. So this is fried ice cream. Now I'm going to take a bite, and I'm going to get it nice here so you can see. This is still very much frozen. And I'm going to take a bite while it's fresh. So good. All right, so let's talk about this. So we made fried ice cream, which sounds bizarre. Just the name of it sounds like it shouldn't work. But why does it? So before I tell you, I'd like for you to think about this. So I think this is always a fun part of science. Ask yourself questions. Why do I think this works? Because obviously it does. You saw me right in front of you make this dish. So what do you think? All right, so there's a really good answer for that. There's two things that are really making this dish work. And believe me, it does work. So, we only put it in there for a few seconds. So, there's not a lot of time for heat to transfer in here. Now, the other thing is that I didn't just put a scoop of ice cream in there. If you were to put a scoop of ice cream without the coating on there, it would not do even close to as well cooking it in. So let's talk about why. So you probably think about temperature quite a bit, but you might not think about what temperature actually is. So when somebody says something like, don't open the door, you'll let the cold in, it's just an easy way to talk about this. That's not really what's happening. Instead, you're letting warm out, because what heat is just energy. So heat is energy, and it's how fast the molecules in something are moving. So that's why if you've watched this before, when we talked about things changing state, it takes more energy for something to be a liquid than it does a solid, and even more energy than that for it to be a gas. So keep that in mind, that heat, when you're heating something up, you're transferring energy. So let's run through how this energy is transferred. So I have this hot plate plugged in right here. I'll leave it on for now. I think we might make another one here so I can show you again. So we've got the hot plate turned on. So it's using electricity to heat up this base right here, the hot plate. That is transferring heat into the pan and into the oil. Now, real quick, you can't see it here, but you might have noticed this. So I had a clean pan and I had hot oil in there. Now, you might have noticed that that oil was not bubbling. It wasn't boiling. The only time you saw bubbles in it, if you're following along at home, this should be the same for you. The only time you see bubbles is when I added something into it. Now, that's because a lot of people, when they see something frying, they assume it's the oil that's boiling, but what's actually happening is it's releasing air things from the, it's releasing air around the things that are inside of that. So I just think that's an interesting thing. So this oil is hot because we've transferred heat into the oil. Okay, are you with me so far? Okay, if you want to pause and think about it, that's fine too. So these are concepts that they're not necessarily really hard concepts, but I think it's things that people don't tend to think about in their daily life. So another important thing to consider is that energy is never created or destroyed. It's just a constant thing. It's just transferred. So anyway, and I can talk to you about that more later. There's a lot of really interesting things about that. All right, so this oil is hot because it's got a lot of heat that's being transferred into it. Now, it's losing some of that heat. When I put my hand above it, I can feel that it's hot around it. A lot of that's leaving it, but I keep adding more heat into this. So this oil is staying very hot. All right, so what happens when we put this ice cream into that oil? Now, if I were to just put a scoop of ice cream into there, if I put it in there for just a few seconds, I think the core of it would probably still say it's maybe a little frozen. But the big thing for fried ice cream, and by the way, the inside of this is still frozen. The big thing for fried ice cream, though, is that it's got what's called insulation. So this shell that we put, that's the part that gets that absorbs most of the heat. And this is actually how things work for frying pretty much anytime you fry. The outside gets a lot more heat than the inside. And when it forms up a shell, then it basically will stop most of the heat from getting inside. So insulation is basically creating a layer that stops heat from getting into something. Now, you've probably heard insulation used in the opposite way. So, and you're exactly right on this too. Insulation can also stop heat from escaping. So if you want to try this for yourself, if it's still cold when you're watching this, you can pause this and do a really quick experiment. You can go outside without a coat on, and you can see how quickly you get cold. And then you could go outside another time with the coat on. As long as it's the same temperature, you should notice a big difference. So if you go outside without a coat on, you're going to get cold very quickly, assuming it's cold. But then once you put a coat on, you'll notice you get cold a lot slower. So the reason for that is your coat works the same way. It's insulation. So it's creating a layer between you and the air. So you aren't losing heat as fast when you're wearing a coat outside because it's stopping heat from escaping from you. So insulation can work the same way. It can stop the heat from getting in. Now, you might be thinking to yourself, well, Zach, but if I wear a coat on a hot day, it's not stopping the heat from getting to me. I'm still very, very hot in the coat. And that's right, because you're still giving off heat into that coat and it's bouncing off back into you. So the reason that it works well for insulating something cold, like ice cream, is because it's getting heat from the outside, whereas the ice cream would absorb that heat instead of giving off more heat. Whereas if I were to fry something that was already hot on the inside, it would just be cooking. So I'm going to take another bite of this. This is very good. I haven't had fried ice cream in a while. That's a fun treat. All right, so what we've got here is insulation at work. The same way that your coat works, it's working for this. So you've got the egg whites help to create a really strong barrier, and then you've got these cornflake barrier on the outside of this that gets crispy and stops the oil from seeping into this as well. So it creates a really good insulation. This is the same reason that your house has insulation. So wherever you live, if it's in a house, an apartment, a trailer, or a car, it's going to have some sort of insulation in it to keep it from losing heat when it's cold and from getting too much heat when it's hot. Now, a car, you might notice, gets very hot in the summer, and that's because of the windows. It actually traps heat inside. That's called the greenhouse effect. All right, so that's a little about how it works to make the fried ice cream. So the insulation makes it so that just the outside is absorbing the heat and it's not making its way into the inside. And if you wanted, you could just try putting a scoop of this in while you put another scoop the same size of just ice cream and watch the difference when you take them out. So if we put it in for longer, or if I were to just let this set out for a while, then the heat would transfer in. So something really important to keep in mind with heat is that it always wants to balance out. It's called equilibrium. I've talked about this before. But if I set out a bowl of ice cream, then just on the counter, the room right now is what you'd call room temperature. But the ice cream is a lot colder than that. So it has a lot less of the heat energy. So what's going to happen? All right, so the heat energy is going to want to balance itself out. So if I were to leave this ice cream for a couple hours, so right now, it's still fairly cold. I don't know exactly how much, maybe 30 degrees, where it's cold. But I'd say it's, well, I can actually look on here. It's 68 degrees in this room right now. And then if I were to leave this and come back 2 hours later, the ice cream would also be 68 degrees because it would balance out. It's not going to affect the room that much because it's such a small thing. Now, if I were to have a square that is, let's say I had a giant block of ice, maybe 6 feet by 6 feet. Now that might actually change the temperature of the room enough. But this is so small, then it's not even going to be a full degree that it would change this room. It would be 0.0000 something, I'm sure. All right, so that's all about the heat of this. But that's not the only thing that I think is interesting about ice cream in general. So ice cream you make by emulsifying it, which basically means you're adding air bubbles, similar to the way you made your sort of meringue earlier. And it's combining cream with sugar. So you combine cream and sugar, and then whatever mixes and flavorings you want in it. This is just vanilla ice cream. By the way, I didn't mention this earlier, but you can use whatever kind of ice cream you want in this. I used the plain ice cream without mixes in it because it's going to be more consistent where the heat travels through it. Now, heat travels through different objects differently. So heat is going to travel through different objects at room temperature differently. So I'll show you what I mean. All right, so I've got water in this. So right now, if I touch this glass where the water isn't, it's going to feel not really like any sort of temperature. It's kind of hard for me to feel because I've been holding a bowl of ice cream, but if you would touch where the water is, it actually is just a little bit cooler. And if I were to actually touch the water itself, it would feel much cooler. Heat travels differently through different objects. All right, so anyway, but if you want to use an ice cream with a mix in it, it shouldn't affect it that much. So let's say you want to get like Rocky Road, anything like that, go crazy, get whatever your favorite kind of ice cream is. It will be great. All right, so it's cream mixed with sugar, and it's beaten to get air bubbles in it, and then it is put into an ice cream machine, which basically freezes it while keeping a bunch of air in it. Now, if you want to make it a little more rich, you can add egg yolks, not egg whites. So if you add egg yolks into that process, then you get custard. So that is the difference between custard and ice cream. Custard has egg yolks in it. All right, so what if you're lactose intolerant? Well, you can get dairy-free ice cream. You could also get sherbet or a sorbet. I always get confused between those two words, I will admit that. So if you do too, that's not a big deal. So, all right, you can find dairy-free alternatives to this. You just need something cold and somewhat creamy. So ice cream, it's because it's that cream, so it's kind of hard to get a non-dairy type of cream, but you could get like an almond milk base of ice cream or soy or oat or hemp. There's a lot of different kind of milks now, isn't there? And also, I think it's interesting, so you might not know this, but the actual majority of the world is lactose intolerant. Only Northern and Western Europeans and some sections of Western Africa really have the ability to process dairy. The majority of the rest of the world does not. And that's because these are the people that domesticated dairy animals. So if you look at those government issue food charts, those are actually recommendations. Those are actually very inaccurate for the vast majority people in the world. I think they're honestly kind of funny. But if you're not lactose intolerant, go ahead and enjoy ice cream and have it without too much of an issue. In moderation, that's always the key to these things. All right, so that's a little bit about how ice cream is made, but why do we like ice cream so much? Have you ever thought about that? Oh, it's so good. The textures are so good too. Texture in food is so important to me. All right, so why do the foods that taste good to us taste good? It's a really good question. So think about ice cream. Ice cream is an absolutely loved food by so many people. So think about what's in it. Well, it's creamy and it's sweet. And the people, well, I'll get to that one in just a second. So it's creamy and it's sweet. So let's talk about both of those things. So what does sweet mean? Well, sweet means calories. And calories, so this is going to be weird for a lot of people. It might actually be less weird to the kids than it is to the adults because adults are used to thinking in the opposite way that I'm going to be talking. But keep in mind, for our ancestors, the goal was always to get enough food. We are unusual in our time right now in that we have a surplus of food. So a surplus means that we have more than we need. So we actually focus now on eating less or raising your metabolism so you can eat more. But it's always about cutting calories. Well, that is never what our ancestors would have been talking about. They would have wanted to get more. And sugar is a great source of calories. So sugar means energy. So when you eat sugar, think about when you take a bite of an apple. That is full of natural sugars in it. And you take a bite of that, and that is energy for you all day long. So it's sweet. So think about before processed foods. You got to just move processed foods away from your mind because they mess up this whole idea. But think about what food used to be like. So if your ancestors tasted an apple, it was sweet. And so they evolved to think sweet means energy. Sweet is good. So the foods that taste really good to us are sweet foods. All right. Now what about creamy? Well, cream means fat. And fat also means energy. But it means long-term energy too. So the taste of cream, because that is what cream is, it is the fatty part of milk. For our ancestors, cream tasted amazing, and it still tastes amazing to us because it's full of fat. Things that are full of sugar and full of fat taste really good to us. So apples, any type of fruit, I used to use apples because they're a really typical fruit, but any type of fruit, things like cream, butter, a cut of prime meat with a lot of fat on it, it tastes really good to us because because to our ancestors, it meant energy. It meant dense energy, lots and lots and lots of energy. All right, so now I want you to take a look at ice cream mixes. So if you look at the types of ice cream that are popular, I want you to notice what they have in common. So really think about that. I've been standing here long enough now, this is mostly melted, but it still tastes really good. All right, do you have any idea? All right, so if you look at ice cream mixes, you can usually divide them up into two categories. They're usually either a sweet, which tends to be fruity, or a savory, which tends to be something with salty types of mixes in there. So think about, so the fruit ones are gonna go with everything I already talked about with the sweetness, and the ice cream, no matter what, is gonna have that savoriness in it. That's why people love ice cream. They also like sherbet, but not as well. So just kind of statistically, people get way more ice cream than they do sherbet. Sherbet is good, don't get me wrong, but it doesn't have the creaminess of ice cream. All right, so then those ones that are fruit mixes, they're going to go with whatever I said for the sweetness. But think about those ones that are savory, which they almost always have something salty in them too. So savory and salty, those are also things that taste really, really good to people. So think about all the snacks that you like to eat, a bunch of them. I can guarantee you, if there's a snack food that you like, it's probably either sweet, salty, or a mix of the two. So think about anything like potato chips or pretzels or just any salty snacks. There's a lot of them. Those are going to say the same type of exciting nutrients to our ancestors as well, because you might not realize it now, but salt used to be a hard thing to get. So it was one of those nutrients that was rare. All right, so anything with salt to our ancestors would have tasted really good, and that's why it still tastes good for us now. So sweet, salty, creamy, those things signify sugar, fat, salt. Those are things that everyone still today needs, but for our ancestors, they were rare. So the foods that taste best to us now are the ones that were rare to our ancestors. Now, here comes the problem. Today, most of the food, well, I shouldn't say most, but yeah, let's say most. In America, most of the food that people eat is packaged in some way. It's somehow processed. And that processing usually involves lots of sugar, lots of fat, and lots of salt. So it's not rare to us anymore. It's in all of our foods that we eat, but it wasn't to our ancestors. So for our ancestors, these were the rare foods. So eating something like leafy greens, it's okay, but it's something that they would have been able to get really easily and they would have eaten a lot of. So they taste okay to us, but the things that were rare, so you got meat has fat in it, dairy has fat in it. You've got salt is hard to find in nature. And you've got sweet. You can only really get that from fruits and some roots of plants. Think carrots are really sweet, or sweet potatoes. So it's things that are a lot harder to find in nature. But in the last, maybe 70 years, that's completely changed. It's important to realize the time we live in now is so different than that of even 100 years ago that it's almost unrecognizable, the food we eat. So now it's so easy you can go to the store and get a bag of potato chips. And those potato chips, or even this ice cream, they're going to taste good to you because it sends the same signals in your brain that it would would have sent to your ancestors of, oh, wow, this is a rare nutrient. Problem is, it's not rare anymore. And these things that were rare that everybody needs in their bodies, we're getting too much of. So that's why I said moderation for these things. That is really actually very important because these things are all necessary for us. Everybody needs sugar. Everybody needs salt. Everybody needs fat in their diets. But when you have too much of it, it can cause problems. That's actually why heart disease up until probably, again, 60 or 70 years ago was actually considered to be a rare condition. It didn't really happen very often. But now it's actually the leading cause of death in America. So I think that's interesting to keep in mind. It is your ancestors, their ancient brains that are basically telling you what foods taste good and bad, and it's still having a lot of effect on you. So even when you know this, I know that the reason this ice cream tastes good to me is because I've got those signals firing my brain. It doesn't stop it from tasting good to me. Also, the difference between sugar in this that I added, that pure sugar, and sugar in an apple, is that sugar in an apple is more complex. So it actually gets digested in your body over the course of an entire day. Whereas that sugar I put it in, it gets digested much, much quicker. So it goes into my body, I get a burst of energy, and then that energy leaves. That's why people always talk about things like a sugar rush. All right, so we've talked today all about ice cream, how to make fried ice cream, how heat works, how heat gets transferred, all of that wonderful stuff. By the way, I find this interesting talking about sugar too. I just remembered. So people will talk to you about things being addictive. And if you're old enough, you probably talked about this as part of your schooling, whether you're doing public school, private school, or being homeschooled. This is something that I feel like is fairly common to talk about things like drugs, but you can actually, as a human, be addicted to any substance. And actually, there are things that are far more addictive than the things that are legal. Now, I'm not saying that those things shouldn't necessarily be illegal. You can form your own opinions and do your own research on that. But what I am telling you is that there have been multiple studies that say that this sugar is actually more addictive than cocaine. Now, if you don't believe me, I would challenge all the adults, try to have no sugar. And by that, I mean no processed sugar. You should definitely still get some sugar, like complex ones from fruit and vegetables. Try to have no processed sugar for a week and see how your body reacts to that. So that's my challenge to you if you want to take me up on that. I think that's something really interesting. So if you want to see that again, I think I'm just going to make another one of these. So if you didn't figure out with the heat transfer before, I want you to figure out, again, why did I put this right here, this pot holder, between my ice cream and the counter? I'm not going to tell you. I want you to think about why that is. And I think you are all very smart people. You have great critical thinking skills, and I bet you can tell me why. Listen to that sizzle. There you go. I want to show you a fresh one before we end. So look at that. That is fried ice cream. So as always, feel free to reach out to the library with me with any questions. If there are anything that was unclear, reach out to me. If you have any corrections, I definitely want to hear them. If you have any questions about science or anything in general, I love questions. Some of the best questions are the ones that people think of are silly questions until they really think about them. Things like, why is the sky blue? Can a bee sting another bee? Things like that. They are great questions when you really start to look at them. So I love hearing your science questions. Feel free to send them to me. You can give us a call, an email, message us on Facebook. You can't do comments on this video because it is made for kids and there are no comments on made for kids videos on YouTube. But you can also give us a call, stop in. So thank you very much. Again, my name is Zach. This is Hudson Public Library in Hudson, Iowa. And remember to stay curious. Thank you. Bye.